Continuous compounding. If P dollars are deposited at a rate of interest R, compounded continuously for T years, then the compound amount A in dollars on deposit is often given in the formula A equals P times E to the RT, often known as PERT. Now, this continuous compounding is totally different than the previous video you watched on compound interest. So compound interest is where the interest is compounded quarterly, semi-annually, monthly, yearly. However, this one compounds continuously. So suppose $5,000 is deposited in an account paying 3% interest compounded continuously for 5 years. Find the total amount on deposit at the end of 5 years. So the key word here is compounded continuously. When you see that, then you know you're using the PERT. And again, those that has compounded other time periods such as quarterly, biannually, monthly, all of those are just regular compound interest, but continuously compounded is when you're going to use the PERT. All right, enough. Now let's go ahead and get started. So we were given that $5,000 was put in or invested here. So that 5,000, we're going to remove the P and replace it with 5,000. The interest is 3%, so it's written as a percent. You can write it as a decimal by simply moving the decimal place 2 places to the left. 1, 2, insert a 0 and a decimal there and get rid of the percent symbol. And so written as a decimal would be 0.03. Okay? So you're going to remove the R and replace it with 0.03. Next we have T in the formula. So you're going to remove the T and replace it with what we were given for the time, and that's 5 years. So replace it with 5. So when we do that, it's going to look like so. Next, we want to go ahead and let's go ahead and do this multiplication. You actually can do all of this if you have a scientific calculator. You can do all of that in the calculator at once. Just simply type in 5,000 and then press the base E key, the natural E. You should find it there. You may have to press second to get to a back key to get there. And then you're going to raise E. So E is a number, by the way. You're going to raise that to 0.03 times 5 and press enter. So as I said before, you can do it all in one keystroke by simply typing 5000 E raised to the 0.03 times 5 and press enter, and the calculator will give you the value. Okay, another way you can do it is to go ahead and do just the exponent part, the 0.03 times 5, and you're going to get 0.15. But you still have to perform that calculation of 5,000 times e to the 0.15. And again, you can type that in the calculator, 5,000 e raised to the 0.15 and press enter. And what you'll get is the approximate value that you see here, $5,809.17. Suppose that $8,906.54 is invested at an annual rate of 3% for 9 years. Find the future value if the interest is compounded as follows. So let's compare these interest periods, compound interest. So we're going to, one is going to compound semi-annually. And you know when it compounds semi-annually, that's twice a year. And then the other is going to be compounded continuously. And let's find out which one pays the most. So because this is semi-annually, that's going to be your regular compound interest formula, which is totally different than continuous. For continuous, you're going to use the PERT. For semi-annually, you're going to use a regular compound interest. And the formula is as follows. So we're going to remove the P, the amount put in, and replace it with 8906.54. We're going to remove the R and replace it with, you got it, 0.03. We're going to remove the N and replace it with what? What does N mean? Yes, it means the number of times that it was compounded. And remember, semi-annually is twice a year, so remove N and replace it with a 2. You're also going to place a 2 that is going to be raised to that N times the time. The time is 9 years, so you'll have 2 times 9, which is 18. So ultimately, it's really going to be raised to the 18th power. And again, you can do all of this with your calculator. You would just simply press 8906.54 parentheses 1 plus. If you have a fraction key, you can go ahead and type 0.03 in the top and 2 in the bottom. If you don't have a fraction key, then you'll type 0.03 divided by 2, close parentheses. And then you can either type 2 times 9 and press enter, or you can press 18 and enter. Either way. But again, the calculator will do the calculations for you. So that is how much will be in there in the future after 9 years. Now let's do the calculations for continuously to see how much money we'll have in there after 9 years if it's compounded continuously. So remember, continuously we use the PERT. We're going to remove the P and replace it with 8906.54. Our rate, we're going to remove it and replace it with 0.03. Our time, we're going to remove the T and replace it with the 9. When we do so, it's going to look like so. And again, we can do that on the calculator by pressing 8906.54 and then press the E key, raise it to the 0.03 times 9 and press enter. Now, you could also just do the exponent 0.03 times 9. That's going to give you 0.27, but you'll still need to do the calculations there. The bottom line, look at those amounts. They are so very close to each other that it really isn't that big of a difference in compounding here semi-annually for this amount versus continuously. When you have that amount along with the rate and the number of years here, the difference is not very much at all. But again, I just wanted you to get a little practice and know the differences between calculating during a certain time period with the regular compound interest and then compounding continuously.